Today we're going to continue our discussion on exponential growth and decay. The objective that you were writing down for 7.2 is I will be able to define and determine the differences between growth and decay. When you're looking at growth, you're looking at the graph from left to right. The first example you see here is it is rising from left to right. That is growth. As you look at it from left to right, if it is going down, that is decay. We also talked a little bit about yesterday that the A, or the base, if it is greater than 1, then it is growth. And if that A is less than 1, then that would be decay. So we can decide from both an inequality or equation as well as the graph whether it is growth or decay. Once you have the objective, go ahead and move on. So let's take a moment and quickly review exponential growth and decay. We will see the equation in the form y equals b to the x. B is your base and x is the exponent. Now, exponential growth is a function that is always increasing, meaning it's positive. Exponential decay is a function that is always decreasing, which means it is negative. And the way you can tell just from an equation whether it is growth or decay is you simply look at this b number. If this base is greater than 1, it is growth. If the base happens to be less than 1, it is decay. So the number that has the exponent attached to it is the number that determines whether or not it is growth or decay, increasing or decreasing. So let's take a moment and visually see on a graph. Yesterday in 7.1, we merely just looked at the equations and that was it. But now we're going to see why that is what it is. If we have the function f of x equals 2 to the x power, x is what we are subbing in for. So over here on our t-chart, the first x that we're going to sub in is negative 2. That means we're going to have 2 to the negative second power. If you remember yesterday from Mr. O'Weiler, we talked about that the negative exponent means we will take the inverse of our answer. So if I ignore the negative for just a moment and I do 2 to the second power, 2 times 2 is 4. But I need to take the inverse of 4, which really is 4 over 1. So we're going to write the reciprocal 1/4. So 2 to the negative power is equal to 1/4. So now let's do the next one. If the exponent is a negative 1, that means we would just calculate 2 to the first power, which is 2. But because the exponent was negative, I need the inverse of 2, which is 1/2. Now hopefully you have memorized that anything to the 0 power is 1. And then let's move now to a positive exponent. 2 to the first power. Remember, we're subbing this in for our exponent right here. 2 to the first power is just 2. And then our final one is to the second power. 2 to the second power is 4. So now we're going to take a moment and we're going to graph these points. The first one in red is the point negative 2, 1/4. So negative 2, but I'm only going to go up 1/4. So now let's plot the next one. Negative 1, 1/2. So negative 1, 1/2. And then let's go ahead and graph the next one. We got the point 0, 1. And then we've got in yellow 2 to the first power. That's x is 1, y is 2. That's the point 1, 2. And then our last point is the point 2, 4. So 2, 1, 2, 3, 4. Now remember, as you go to connect these points, they are approaching the asymptote, which is the x-axis. That will never cross over or go below the x-axis. As you look at this function from left to right, it is increasing. So that is growth. Now we could have guessed growth just by looking at the original problem, the equation with the base. If you notice, the base right here is greater than 1. That means it is in fact growth. Now let's not forget domain and range. That has not gone away from August from Unit 1. Looking at the domain, which is your x values from left to right, this graph goes forever to the left, and it's going up and to the right forever. So that's from negative infinity to positive infinity. The range is how low it goes, which is right here. It is approaching the y line, or the y equals 0, but it never quite reaches 0. So we're going to use parentheses, not brackets. And it goes as high as forever, so positive infinity. Take a moment, make sure you're good in your notes. I expect to see the equation, I expect to see the table, and these 3 statements. If you want to go ahead and pause and make sure you get all 3 down in your notes for each example. Here's our next one. Y equals 1/2 to the x power. That means when we come over here to sub in, we have 1/2, but the exponent is going to be a -2. So if we have 2 1/2s, 1/2 times 1/2 is 1/4. But remember that negative exponent means take the reciprocal, flip the fraction. 1 over 4 would be 4 over 1, which is just 4. That's the point -2, comma, 4. So -2, 1, 2, 3, 4. And then let's plot the next point. If we have 1/2 to the negative first power, well, 1/2 to the first power is just 1/2. But then I take the inverse, or the reciprocal, because it's a negative exponent, and it's really a 2. That's the point -1, comma, 2. Moving to our next favorite one, anything to the 0 power is, you got it, 1. That's the point 0, 1. Hopefully you're starting to see over here that the points are going down, that it is actually decay. Now if we see a pattern here, it's going from 4, cut it in half to get 2, cut it in half to get 1. So if I were to make a prediction and I cut the 1 in half, that would be 1/2. Let's see if that's true. 1/2 to the first power means I just have 1, 1/2, which does equal 1/2. So there's the point 1, 1/2. And for our final point, let's sub in a 2. We have 1/2 to the second power. That means I have 2 1/2s. 1/2 times 1/2 is 1/4. So that is the point 2, comma, 1/4. When we go to connect these, we will notice that it is decay. It is in fact going down from left to right. Again, the asymptote is where y equals 0. It is approaching the x-axis, but it will never ever cross over it. It is in fact decay. And we know that from 2 ways. From left to right, the graph is going down, as well as in the equation, the base, 1/2, is less than 1. Now, domain, from left to right, this graph goes forever to the left, it goes forever to the right. So that is negative infinity to positive infinity. And then our final one is our range. How low does it go and how high does it go? Well, as far as how low it goes, it's coming as low as y equals 0, but it never quite hits 0, so it would be parentheses instead of a bracket. How high does it go? Well, it goes forever, which is a positive infinity because it's going up. So make sure that you have the equation written, the table written, and the 3 questions. So take a moment, look at these 2 examples, and tell me if they are growth or decay. In your notes, I would like you to write the equation. I would like you to underline or circle the base. That is 0.25, which is less than 1. So this is an equation that is decay. Looking at the next one, I'd like you to underline, circle, highlight the base, 6. That is greater than 1, so that equation is growth. Make sure you are okay identifying from the equation by simply looking at the base. So take a moment, you don't need to write this down, I just want you to look. When we start to look at the Final Four for the basketball season with the NBA, the question is, how many teams do we start off with? Now, if you're a basketball fan, you might already know that. If you, however, are not a basketball fan, we're going to take a moment and count. This is the table that they set up. We have 1, 2, 3, 4, 5, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. We start with 32 teams in the Western Conference and 32 teams in the Eastern Conference. So altogether, on round 0, before the competition starts, we have 64 teams. Now, just in case you're not sure how this works, we have 2 teams that play, let's say this team and this team, and only one person can win. So we went from 2 teams down to only 1. So it looks like after 1 round, how many teams will be remaining? Well, you could count how many end up remaining, but you will notice basically it's being cut in half, because out of 2, only 1 survives. So half of 64 is 32. Once we get to round 2, now that number 32, those 2 teams, only 1 person can win out of those 2. So that is the 32 cut in half again, which is 16. And then after the 3rd round, out of those 16, only 1 person can be chosen. And when you cut the 16 in half, you will end with 8. Hopefully you are seeing this pattern over here, that we're cutting them in half. 64, 32, 16, 8, and then we would have 4 and 2. If we cut the 2 in half, we will end with 1 team. So how many rounds did it take for us to get a final championship where only 1 team can win? So in your notes, I do not need you to draw the table, but I do need you to draw this table for me, because then the questions on our next slide we can go ahead and answer. How many rounds did it take? It took 6 rounds in order for us to have a winner. Now you are going to make sure that you've already drawn this table, and now you're going to make sure you draw the graph. On the x-axis, you have labeled the number of rounds that we're on and the teams. You will number your axes, and then we will graph them. We start at the first round with 64 teams. So if I estimate 64 is right about here. It is then cut in half, and we go down to 32 after 1 round. And then that 32, remember, was cut in half to 16. So the next round we have only 16. And then after that, that is cut in half to 8. So after 3 rounds, we only have 8. And you can slowly see what kind of equation or function this is. After round 4, we're all the way down to 4. And then after round 5, we're all the way down to 2. And then after round 6, we have our final answer of 1. But notice we never hit 0. We will never end up with exactly 0 teams left over. It will actually stop right at 1 as far as the y numbers go. So let's take a moment and write an equation to represent the situation. So we're going to write y equals, and our initial or starting value, if you remember from yesterday, is the first number, 64. In parentheses is the base, and then it is to the x power. The question is, what is the base? What are we multiplying by to get to the next number? What I'm asking is how to get from 64 to 32, from 32 to 16, from 16 to 8. You could say we're dividing by 2, which is true, but what are we multiplying by? What is the same as dividing by 2? Well, you take the reciprocal, it's multiplying by 1/2. We are cutting the numbers in half. So the function that could be written as y equals, or f of x equals, the original starting number of teams is 64, and each round they are cut in half, and then the x represents the number of rounds. Once you are good, you have the table, the graph, and these 2 answers. Feel free to go ahead and move on. That is it for 7.2. Once your notes are complete, you may go ahead and begin working on your 7.2 assignment.